Good morning, everyone. Can you see my screen?
We're good, thank you.
Okay. Well, I'm really happy and delighted to be presenting this presentation today. Yeah. So I want to thank, first of all, Hamilton Thorne, Cynthia, for organizing this program, our moderator, Dr. Tex, for a wonderful opening presentation on artificial intelligence in reproductive medicine and embryology, and to Charles Borman for a wonderful presentation related to all aspects of clinical embryology. That was really impressive. So my presentation is going to be more of a small compared to what Charlie has just presented, because the life in andrology field is still pretty ancient in terms of AI, but I'm going to give it a try. So I'm going to talk about my title a little bit later and explain why I chose what I chose. So let's start. And well, starting with the conception, I mean, it's something which is a problem in at least 15 to 25% of couples which fail to conceive within 12 months. For many of others, it happens without any effort, but there are couples which really have problems. And according to the data that we know now, is that at least in 25 to 30% of the cases of these couples, the male factor is the sole problem or the sole cause of their infertility, and compared and combined with male and female, that can add up to almost half of all cases of infertility. According to the WHO, about 200 million couples are considered to be infertile, and out of that, about 50% of them are considered to be due to the male factor infertility. So it's a fairly big problem around the world. And the main reasons for this increase in male infertility is because of a progressive decline in semen quality over the last many years, many decades, at least the data for last 7-8 decades, and changes in our social life, where both men and women are waiting for the ages of 30, 40 to get married in many cases. And there is an increase in the rates of sexually transmitted diseases that we see, which is really very common in many of certain regions with conditions such as chlamydia, gonorrhea, etc. Really, they just are exploding. And environmental issues with phthalates and many of the pesticide endocrine disruptors are all over the world. In many places, you will find this is just something that is you cannot escape. Occupational exposure, whether it is through the industrial pollutants or automobile or a variety of other pollutions, is just causing so much health-related problems, and certainly affecting our reproductive health. Lifestyle factors, which have become very much a focus of our attention, lifestyle such as obesity and cell phone use, stress, alcohol use, smoking, and unhealthy diet. These are some, but there may be more. And just to give an example, I mean, I think people use cell phone just like it is part of their body, and not realizing that there is electromagnetic radiation which is generated by cell phone, both in the talk mode as well as when it's in a standby. And there are studies after studies which have demonstrated that can impact on your health, and certainly studies which have shown that it can impact on your male reproduction, and specifically on your semen quality. Diabetes and erectile dysfunction are other conditions which have become like all over the world very important diseases, and they all impact on the fertility. So the studies have shown that the changes that are happening in terms of the sperm count is not just limited to one particular area, but they are happening all over the world. We are seeing that there is a tremendous decline over the last 50, 60 years in all semen parameters, whether it is sperm count, whether it is motility, whether it is morphology, and that is really impacting on the cases which are being presented for infertility. So the traditional method or traditional algorithm for evaluating the male infertility consists of trained reproductive physicians who take a reproductive history, do a physical examination, and conduct a variety of investigations, starting with semen analysis and then going to further examinations such as endocrine and radiographic tests. So in the context of male infertility, semen analysis is one of the most important laboratory tests that has to be done on all men presenting for problems related to infertility. So semen analysis is a very simple and considered an easy test, and what it includes is a macroscopic examination which can be done without the need for a microscope, and then the microscopic examination which includes concentration, motility, morphology, and many other parameters which require the use of a microscope. However, semen analysis, which is considered as very simple test, is highly inaccurate because it is a subjective test. And although many attempts by World Health Organization in terms of developing standards over the last 40 years, starting from 1980 to the last one in 2010 called the 5th edition, have provided a great deal of standardization, but still the test has remained highly subjective and it is very difficult to standardize. And because of these reasons, in the United States, it is considered a high complexity test by CLIA. So it is because of the subjective nature, it requires a large amount of effort in terms of training, competency training, and then the use of quality control and quality assurance in order for the laboratory staff to be trained so that the quality of the test that they will perform is reliable. And the reason for why this happens, because almost 90% of the laboratories which are performing semen analysis are not able to perform it correctly. And the reason is that semen analysis or the semen production is cyclical. And the production of sperm from the testis can be in one semen sample could be 20 million, and after 6 months that can jump up to 100 million or 200 million, as you can see in the WHO guidelines. So there is an immense amount of differences in terms of variability in terms of the sperm production. Then there is a lack of standardization in terms of protocol, training, quality assurance, and furthermore, there is a presence of intra-individual variability and a variety of things which impact on the measurements, such as for concentration, use of counting chamber, sampling error, and a variety of training experience can impact on the results. Similarly, in the morphology, which is even more complex because it has to be evaluated manually, and then you have to categorize the sperm whether it is normal or abnormal using the WHO classification system. So for a variety of these conditions which impact the decision for conducting the semen analysis manually, it can increase the rate of error. And the increases which occurs, for example, changes from a sample which is oligospermic can be rated or classified as normozoospermic, or a sample which is asthenozoospermic could be classified as normozoospermic. So all of these can really impact on the decision that the clinicians has to make in how they are going to manage their patient through the treatment, and certainly that can result in a clinical decision which can be impacted. Now, manual semen analysis, for many of you in the audience will consider it as a very simple test, but I beg to differ. If you look at this diagram, semen analysis is not a simple test. It consists of a number of steps, and you can see there are things which are to be done after another, and there are almost 9 steps that you can count, or maybe more. And this can take anywhere between 15 to 20 minutes for a laboratory technologist to evaluate, to complete. And that is not all, because further to a routine semen analysis, there is a sperm morphology, which is to be conducted as part of a complete semen analysis. And even the fastest method, which includes which is the diff-quick method, a fast method of staining and scoring the slides by WHO strict criteria, can take almost 13 steps, 12 to 13 steps, and with the preparation of the smear, drying, etc., it can take an hour of your time. And that really is a big problem, because the more the steps means more possibility to make the mistakes. So what can we do to overcome these problems in semen analysis, which is a very ancient test, hasn't really changed in over 100 years. Large number of companies, including Hamilton Thorne, over the last 40, 50 years, at least since the early 80s, have developed a variety of systems called computer-assisted semen analysis system. And these are some of the industry leaders, Microptic, Hamilton Thorne, MES, but there are many more manufacturer and systems in the marketplace. The CASA system are a great advancement in technology. With the help of an operator, you can semi-automate the identification of the spermatozoa in terms of being normal or abnormal. But there are factors or conditions which can impact on the results of these CASA system. The sample preparation, the frame rate acquired per second, depth and type of counting chamber that are used can create problems. And the biggest problem is many of these systems really perform poorly. The sensitivity of these systems at high and low sperm count is poor, and they are not able to provide very good results in terms of the count, motility, and kinetic parameters. Also, conditions which are common in semen samples, such as agglutination or presence of debris, also interfere in the results of these systems. The advantages of these systems, why laboratories really buy these systems for their use, and we have many of these in Cleveland Clinic, is because they are busy labs and they need to automate and to standardize their operation. And that is a great thing to do. And it also improves the efficiency. Of course, having a system, multiple people can use that system and get similar results. And it also reduces the inter and intra-operator variability, as we see in manual semen analysis. So the devices are semi-automated, objective, and can be used for large scale testing. But the limitations of this is that they are generally bulky, huge, requires a trained operator to operate the device. They are not completely automated. And there is a inter-operator results unless they are being very well trained, and takes time to complete the analysis. And the biggest limitations are that they are very expensive. So I believe that my previous speakers have introduced this topic really, really well. So I'm going to really move forward with this slide, but just to indicate that the sperm, the use of AI in sperm, or in the case of semen analysis, is the very first application that have come, unlike in the case of embryology or ART, where there are dozens and dozens of applications already being used or are being perfected. We have heard from our previous speakers about the time from R2D2 in 50s to machine learning and now deep learning. So I believe the machine learning in the case of semen analysis is when the operator is actually entering and training the database with the various types of classification, whether according to, let's take a sperm count, whether it's normospermic or oligospermic, or whether motility, whether it's asthenospermic or normospermic, or in terms of the morphology. So there are various types of classification of sperm to identify whether they are normal or abnormal. And in terms of the deep learning, when large amount of such type of data has been entered, then it allows the machine to be able to predict the success of identification of spermatozoa or the test that we are conducting correctly. So in terms of artificial intelligence in andrology, we have a device called LensHooke X1 Pro semen analyzer that works on artificial intelligence. It is an artificial intelligence optical microscopic based technology, and it has been trained using the parameter based on WHO 5th edition criteria. It uses machine learning to avoid subjectivity in evaluating semen parameter, which is really one of the biggest drawback of manual semen analysis. So on the right side is a semen analysis report generated by this particular device, which you see on the bottom, called LensHooke, manufactured by a company Bon Riable. So we can get complete analysis of all the parameters from this device, and on the very bottom are many of the motion kinetics that you're used to seeing in a traditional CASA system. Now let's look at this particular device very quickly. The device itself is fairly compact. It's a little bigger than a iPhone, and it can conduct a semen analysis, a complete semen analysis in just 3 steps within 2 to 5 minutes. It can evaluate, or it can check the pH, it can check the concentration, it can check the motility, it can check the morphology, and I have a small video to show how it works. But essentially, is 2 drops of semen, each about 40 microliter, is placed on a cassette, disposable cassette, and then inserted inside the device here, and then the results will be ready in just few minutes, in 2 to 3 minutes. The measurement range of each parameter for pH is between 6 to 8. Concentration from 0.1 or 100,000 sperm to 300 million. Total motility, progressive motility, non-progressive from less than 1 to 100%, and morphology from less than 1 to 100% by strict criteria. So there is a small video which I'm going to play here to see if it works. Let's see what happens. I had to turn off my laser pointer. Okay, So we, about 2 years ago, we have been conducting studies on this system as the to allow it to be used clinically. We conducted a pilot study and published those results. And what we did was these are the results of our full-scale study, which we have just completed. And we compared the manual semen analysis results with the X1 Pro. So here we had 100 samples where we conducted the samples analysis by manual, by a trained andrologist and a commercial CASA. We chose Hamilton Thorne IVOS and LensHooke. So there were three different types of analysis, or three simultaneous analyses were conducted by WHO. And what we found was that there is a very high degree of correlation in the manual semen analysis and X1 Pro as well as Hamilton Thorne IVO system. So if you look at the results, the correlation is extremely high, almost 0.97 or 0.98 for concentration motility and progressive motility between manual versus LensHooke. Similarly, between manual semen analysis between Hamilton Thorne, and the third comparison was between LensHooke and Hamilton Thorne IVOS. So the device really was the new device, which is X1 Pro, performed really well. Now we conducted an intra-observer agreement where we wanted to see if the same individual, if they conduct this semen analysis multiple times, are they able to correlate well? So we had the same operator conduct 3 different readings and did 10 samples. And what we found is that he conducted both manual as well as manual semen analysis and X1 Pro. Again, the intra-observer correlation is again extremely high, as you can see, more than 0.9 R value for concentration, total motility, and progressive motility. And these results are comparable. Here, the comparison is between manual semen analysis and X1 Pro, LensHooke X1 Pro. Then we did an inter-observer agreement, which is important to see the difference between the different individuals working in the laboratory. And here the comparison was between manual semen analysis and X1 Pro, and each individual conducted the semen analysis both by manual semen analysis and X1 Pro by WHO 5th edition. And here again, the correlation shows very good value. So the design of this experiment and the results that we see demonstrate that X1 Pro and manual semen analysis results are interchangeable or show extremely high degree of correlation when the manual semen analysis is conducted by a highly trained andrology technologist or a staff. The device X1 Pro comes with quality control for the hardware, quality control for the software, as well as quality control for daily operation. And these are called AccuBeat, which is, you probably are familiar, which is part of the quality control that the laboratory are supposed to do before they conduct a routine semen analysis or one using the CASA in their laboratory. And the results for that are mandatory as part of the operation. In terms of the performance characteristic of manual semen analysis versus the X1 Pro, as you can see here, and again, I think the results are very, very good. All the performance characteristics are very high, 100% for concentration, sensitivity and specificity, and high 90s for motility, progressive motility, and for morphology, especially the negative predictive value. So let's look at the morphology performance of manual semen analysis versus X1 Pro, because morphology is really the most difficult test for most of the CASA devices to standardize. And that is one of the biggest problem is for all the CASA systems that are in the market, they have not been able to provide morphology results reliably. So I was very much interested in hearing Charlie's presentation about the morphology, where they have come out with a very nice AI-based app which can provide a very high degree of sensitivity for the results. So here, what we found is that the negative predictive value of the X1 Pro is 98.4%, where if it is greater than or equal to 4% by strict criteria, then it is 98 or 99% accurate by manual method as well. So in terms of recommendation for using LensHooke X1 Pro, what we feel for morphology evaluation, if the results of the morphology, for example, here is 8%, or which is more than 4%, then this individual patient can be classified as fertile or true negative from the results. If, on the other hand, the results are 3%, or according to the cutoff value or reference value of strict criteria, less than 4%, then this can be considered as infertile male, classified as infertile or true positive, and it will require a manual review to double check these results. Otherwise, I think the system works really well. So in terms of what may be the difference between X1 Pro and traditional CASA system, I believe the main difference is that most of the CASA system require an operator, which has to jump in whenever there is a problem, or there are samples which may be difficult samples, or samples which have very low concentration or very high concentration, or they are viscous or have agglutination. So I think that is one of the biggest advantage here with the X1, that it is completely algorithm based and does not require an operator. So again, I think X1 Pro on the bottom, as you see, is fully automated. It takes a clear image of the field of the spermatozoa, and it counts all 100 sperm or which are present within one field, and then it classifies them using the algorithm for concentration, motility, progressive motility, and morphology. In terms of the roadmap where this technology is really moving, the machine has been trained for machine learning for some time, and this is something that is being done by the company. And now, as they are having a large amount of data, because the device or the machine is this particular CASA is available commercially in most parts of the world, approved by the FDA here in the United States, and being available for commercial use in Europe and all parts of the world. So they have a lot more data, and they are training this device for deep learning. For us, based on my experience and our experience in the Cleveland Clinic, we can summarize the unique features of this particular device. The biggest advantages, I believe, is the ease of use. It's so easy that anybody without any training can use it. You don't have to have any training. I mean, you can just walk into the lab and start using it without any training. There is really no space requirement, because the device is so small that it can fit into your palm. Analysis time is just 2 to 3 minutes, 4 minutes at the most. So that is a huge advantage after the sample has been liquefied, of course. And the accuracy is extremely high, and I showed those results with you. It can measure the pH, it can measure the morphology without any kind of staining or preparation of the slides. That cuts down on the time. It is very reliable in terms of inter and intra observer correlation, which we shared, is as much as 99%. And the biggest, I think, winner here is the speed with which the results are available. Within 5 minutes after the sample has been analyzed or has been liquefied, the results are available, and while the patient is still waiting in the waiting area, the physician, or he's talking to the couple is talking to the physician, the results can be seen by the physician on his iPhone or on his computer or wherever, and they can actually use those results to provide what is the next course of action for the patient and for the couple. What is the treatment plan? What is the management? So they don't need to call after a few days and the patient calling and getting anxious and all really frustrated. The results are not available for several days, and there are a lot of wastage of time that is completely gone with the use. So now let's look at why I chose this uh, name of Gulliver's Travel. If you recall in your early childhood, at least I read about it by Jonathan Swift, and there used to be big, really individuals, which we used to call Brobdingnag, and we have those devices actually, which are all there in the marketplace, still there. And then we have these Lilliputian, which I just talked to you. So this is a huge advancement, the very first advancement in the field of andrology. But we have the proof. We have this latest article which just got accepted a few weeks ago and is online, which provides a proof of this technology. So the proof is in the pudding, and the paper is out there in the PubMed, and it shows that the LensHooke device is really a device which provides very reliable results in terms of all the parameters. It's fast, easy, and simple and economical device, and it can be used all around the world, I believe. The take-home message that I have is the new artificial intelligence optical microscopic device has a high level of precision and agreement compared to manual semen analysis. The results of X1 Pro for concentration, total motility, and progressive motility correlate very highly with manual semen analysis done by an experienced individual. Positive predictive value for X1 Pro is 100% for oligozoospermic and about 87% for astenospermic. X1 Pro is a fast, simple to operate device that offers reliable and reproducible results. And moreover, it can also perform morphological assessment, although it requires more training in terms of analyzing abnormal morphological assessment, so that the sensitivity of its results can increase over the time. So thank you very much. I really appreciated the opportunity to share these presentation with all of you. Thank you very much.